Previously, we looked at how we added detail and color to our Project Pegasus terrain using the Pegasus height field material workflow and nodes. Following on from that, we looked at how we created an IDMap using the height field layers to ID node. This IDMap is going to be used to drive the displacement and distribution of materials inside of Unreal Engine. In this video, we're going to look at how we transformed our starting point, which was this, into this result which you see before you, which is the culmination of all of the work that we've done up to this point, incorporating the extra procedural details, the global textures and the ID maps working in tandem to provide both macro scale details and high quality texture details up close and personal to the terrain. In order to accomplish this, we're going to make use of a material that is provided. So you can go to sideeffects.com/Pegasus in order to download the content pack needed to work with this material. This video and series won't be going inside the creation of the master material and its setup, as it is rather complicated, but there's a separate series that we're introducing for Project Pegasus that will go into the kind of main principles and thought process behind how all of this works and why you might want to use this type of material instead of the traditional approach. So with no further ado, let's hop inside of Houdini and start to take a look at how we can export these individual maps and procedural height field data over into Unreal. So I'm going to leave this example project and jump back into the working project that you're following along with. And first of all, let's have a look at how we can export the procedural detail from the height field that we created. This is quite a simple process. We're just going to add in an object merge, and using that object merge, we're going to create a reference to the incoming terrain. That is the terrain before any of our procedural modifications have been added, which you can see there. And then I'm going to use a height field layer operation, wiring both of those outputs in. And I'm going to set it to subtract instead of replace. And there we can see that we now have our procedural data with none of the source terrain height or manual editing visible inside of it. Okay, so next up, what we're trying to do here is overwrite the cache that we've created that's being read inside of Unreal Engine. So if you remember, inside of Unreal, we've set up a digital asset which is looking at a cache of height field layers, which we can see here, layer 1 source, 2 manual edits, and 3 procedural details. If we have a quick little look back at Unreal, we can indeed verify that that's the case, because we have this digital asset here. The top one is responsible for exporting to disk, and the bottom one, we look at the parameters, allows us to update and import each of those layers. So we're trying to overwrite the cache there with the new file, just the one that we've created here. Where we're going to do that, so we're going to put down a file cache, quite simply. We're going to turn off time dependent, and we're going to set the file path to be explicitly created. Then we're going to open up our floating file chooser and just navigate to the source content folder, which contains all of those caches. We simply want to overwrite layer 3 procedural detail, and don't worry about overwriting it because we've got a backup folder here containing the originals. Accept, and then we're going to go ahead and hit save to disk. There's another way to export height field height data to disk, and that is the height field output node. We're going to be using this in a second. The reason we didn't use that here and instead we're using a file cache is because the Houdini engine natively understands how to read BGOs and import them as landscapes if they are set up and tagged correctly. And our digital asset, which loads the Pegasus terrain, takes care of all of that under the hood. Okay, so if we now go over to the IDMap layer stuff that we've got over to the right, we're going to put down that height field output node that we just mentioned. And actually, let's just put down a quick little visualizer so we can see what we're looking at. Yeah, this is a height field ID to layer, which is not something we're actually going to be using. And this is the final result that we're looking at here. But I want to see a visualization that's more indicative of the end result that we're actually going to end up with. So I'm going to put down another height field visualize node, like so. I'm going to go and set the update material to no change. And then I'm going to set up some custom tinting, which is going to go from black to white, like so. And it's going to use as the color layer the ID. So if we have a look at that, we can now see the IDMap that we're going to be exporting to disk, and this is what it would look like on disk. So what we're going to do is with that height field output, going to change a few parameters. I'm going to make sure that it's single channel because it's a single channel grayscale. We don't have any color. I'm going to set it to be 8-bit fixed because it's just going to be the kind of black and white information there with a limited number of bits available. So thing to remember, if it's an 8-bit fixed or if it's an 8-bit grayscale image, it means you've got 255 points or 256 points of data that you can deal with. So a maximum of 256 layers. And then we're just going to navigate to our source content folder again. And this time, if you haven't already got one, you're going to create a textures folder inside of source content Pegasus landscape textures. And then we're just going to name that T_PE terrain IDMap. The name's not super important, and hit save to disk. Hit accept, sorry, and then you can go ahead and save that to disk, like so. And then we're going to copy that output. I'm going to go back to our file, our sort of layer over here, and we're going to see that just above the height field layer, at the end of the kind of material operations we did previously, there's a height field visualize. And this visualize is actually just removing the color from our visualization. So if we look at the node before that, we can see the full color. And we're going to set up a slightly different visualization here by actually putting down a volume wrangle. Don't worry, we're not going to be writing any complicated vex. We're simply going to wire the output of the cavity into the volume wrangle. And we're going to type @height equals 0, which effectively means we're just emptying any height information from the height field there. The point of that is just to allow us to see the color of the terrain without any height information kind of distracting us. Okay, so we're going to take the output of the volume wrangle, and we're going to then look at the parameters of the volume wrangle. And I just realized something that we did mistakenly before, which we will address in a second. So first of all, we're going to set the format to be RGB because this time we are dealing with color information. And we're going to leave it on 8-bit fixed because we want to create an 8-bit color map. And then this is the bit I missed previously, but it's very important, is on the output layers where it says image channel, terrain layer, we're going to hit red. We're going to get the R layer, the green layer, and the B layer as the RG and B outputs. And then we're going to go ahead and hit save to disk. It seems I'm moving a little bit too fast. Maybe I had too many coffees today. So of course, actually that's going to overwrite the IDMap that we wanted to create. So we're going to have to open the floating file chooser and set that to be T_PE terrain color. You won't have these files on disk, so you just need to type that out, T_PE terrain color, although the name is not super important. We're going to hit accept and then save to disk. And then yes. Now we need to remember to go back over to the IDMap output and be sure that we're actually selecting the ID layer as the file that we want to output. Okay, so now we're going to open the floating file chooser again, and we're going to just hit expand path. I'm going to grab that folder so we can open it inside of our Windows Explorer. And if you've ended up with an additional kind of IDMap that we don't want, which I have indeed ended up with, I'm just going to go ahead and delete that one. And now we can see that we've got those two files exported to disk. And just to verify that that is all set up correctly, I'm going to delete them at my end and save them once more. There's our IDMap. And there's our RGB. Okay. Now, there's something that's not immediately clear when we look at this inside of the viewport and the kind of like the Windows Explorer view here. But if we pull it up, you can see there seems to be a bit of a difference in color between the file exported to disk and the height field file previewed inside of the Houdini. And one thing that we need to bear in mind is that Houdini height fields automatically have a kind of gray cast to them, or a darkening cast to them, because that's just the color, the kind of the vertex colors, as it were. So if we just have a look at the height field visualize, you can see that it's not actually completely white. And if we just put down a quick material, like so, which is white, we can see what it looks like once it is completely white. There, it's easier to see if we look at it in unlit mode there. So we're just going to copy that quick material over and inspect our color map again. And we can see that it's actually quite a bit brighter than it looked before. So that's what it looked like before, and that's what it's actually the true colors contained within the height field. And now if we have a look at our terrain color, we can actually see something is very wrong. There's two things. Firstly, this input on the right, the image on the right, is clearly quite a bit darker than the colors that we're seeing inside of Houdini when we look at it in unlit mode with a sort of a white material applied to it. And then secondly, it's a little bit harder to tell, but this is actually a little bit oversaturated and the contrast is slightly off. And the reason for this is because when we export the height field color data to disk, all of this height field color data is actually stored in a linear format inside of Houdini. And when we export to disk, we really want to be exporting it with sRGB. This is displaying the linear images of its sRGB image. So we need to prepare the file for that, and we need to go, first of all, put down the PE, I think it is RGB, no power. Let's have a quick look. RGB power, yep, height field RGB power. Oh no, sorry, not RGB power, actually, sorry. Height field RGB color space. There we go. And yeah, we just want to convert from linear to sRGB. So now we can see this looks pretty blown out inside of Houdini, but when we actually export to disk, it's going to match the color a lot better that we see there applied to the height field. So we get a more truthful representation of the map that we authored. Okay, so we've got our height field out. We've got our height field data out. We've got our color map out, and we've got our IDMap out. And now we're going to switch back over to Unreal and start importing these and setting up the material. All right, now we're back into Unreal. We're going to open up the landscape that we started working on. And we're going to see the unmodified procedural details. So by default, you'll be seeing something similar to this. And first of all, we're going to load in our new procedural detail that we've authored inside of Houdini. So we're going to click on the PE load landscape digital asset, and we're going to go down and check that our directory is set up to point to the correct location. And we're going to check that our mode is update existing and the layer that we are importing is the procedural edits. And if all of those settings are correct and the environment set to Unreal, we're going to go ahead and hit reload. And there we go. We can see that we now have all that juicy, rich new detail that we authored inside of Houdini. So first of all, we're going to select the landscape and we're going to navigate to Content Pegasus Demo Materials Landscape. So once again, you can find this content on sideeffects.com/Pegasus or follow the link in the description. And you'll see that you already have a M Pegasus Landscape Master, which we'll be ignoring for now, and an MI Landscape Instance. And we're going to go ahead and drag and apply the MI Landscape Instance to the terrain. You can see I already had it applied there, so I'm just going to unapply it and reapply it. Okay. And with the MI Landscape Instance, we're just going to double click it and open it up and see what we're looking at, what we're working with. So it will have either opened you up into the layer parameters or to the details tab, and you'll see that there's already a bunch of parameters that have been set. And essentially, we can mostly ignore the detail parameters apart from these texture inputs. And where we're mostly going to be concerned with is the layer parameters tab, which is going to allow us to set up, customize, and define the look of each material layer that we want to apply to our terrain. But for now, we're going to switch back over to the details tab and have a look down at the global texture values. We can see that we've got a color atlas, masks atlas, and normal atlas. We've also got terrain color and terrain IDMap. So we're going to forget about the atlases for now and just go ahead and import our terrain color and terrain IDMap. So we'll open the textures folder inside of the landscape folder. And then we're just going to navigate to where we exported those textures on disk, the terrain color and IDMap. And we'll just drag and drop those into that folder inside of Unreal. And to begin with, we'll drag the terrain color onto the terrain color slot in the material. And you should be able to see that straight away that sort of brings in all of that lovely color information that we crafted inside of Houdini. Okay, so next up, we'll wire in the terrain IDMap texture, and we'll start to notice something kind of funky happening. So in order to see this a little bit more clearly, we're just going to go ahead and turn off the use terrain color for a moment. And we can see that we're getting some color information along where it seems we created the screen map, but we're not getting any of the other layers that are contained within the IDMap. So let's take a look in the IDMap and take a look at what seems to be the problem. Well, as we look through the settings of the IDMap, we can see something that jumps out straight away. We're using a grayscale texture and the compression is currently set to be default. So let's remedy that. Okay, so no change yet. What else could be the problem? Let's scroll down and we can see that sRGB is ticked. Okay, so we already had one issue with sRGB previously today, and that was to do with the representation of the color map. And to get the color map to look correct, we needed to convert from linear to sRGB. On the other hand, we've just exported from Houdini without doing any conversions, just the raw linear data. So in order to get that to be read correctly by Unreal, we need to go ahead and uncheck sRGB. Okay, now we're seeing something. We can see that we're getting layers roughly applied where we would expect them to be, the cliffs, the scree, the sand, and then red for sort of the upland grass areas. So all seems to be in order, or does it? As we zoom in a little bit closer, we can see that we get these kind of black borders around the between the different layers. In this case, it seems to be going slightly red even, and up here especially, we can see get these little red dots. And all of these layers have these kinds of border regions applied, which isn't true to what we'd expect from the IDMap. So why are we seeing that? Well, if we zoom in on the IDMap, we can see that we're getting sort of feathered transitions between the pixels. What this tells us is that there's some filtering being applied to the texture before it's getting rendered in Unreal. So I'm going to have a look further down in the settings, and we'll see that there is indeed a filter setting here. And we want to go ahead and click that and turn the filtering to nearest. Now we can see that those pixel boundaries have now been made hard, which means we have a very clear distinction about which layer is getting applied where. And if we look back at our terrain, those borders are now gone, and we have the different materials sort of blending into each other the way that we would expect them to. So that's very important that you check through the settings of your various textures and make sure that they're all behaving in the way that you would want them to. That brings us to the texture arrays. As mentioned previously, the index texture that we've created, or the IDMap, is simply looking into each of these texture arrays, and it's getting one index, or rather one index from the IDMap is being correlated with one of these textures in this texture array. So rather than just being a single texture with a band of color, what we're actually looking at here is a texture 2D array asset, which has inside of it 0 to 7. So that's 8 individual textures, which are being looked up according to that index. These textures, if we have a look inside of the debug folder, are here clearly being shown as individual textures. The same is true of the ORD, or masks atlas, and last but not least, the same is true of the normal atlas. So in order to make this terrain look correct and rendered the way we want it to, we just need to go through and replace each of these indices with a texture that we want mapped according to that region of the terrain. This is going to be easiest if we work through the color array, and then subsequently, once we're happy with the texture choices for each of those layers, we can go through and fill out the masks array and the normal array. So we can close those for now. Okay. Now we just need to source some textures that we want assigned to our terrain. And the way that we're going to do that is we're going to go to Quixel Bridge. So I'm going to go ahead and click on Window, Quixel Bridge. All right, so once Bridge has loaded and you're all logged in, it's time to start looking for materials. Because the Quixel Bridge library is rather intimidatingly large, the way that I like to go about it is I like to go to the Collections tab, Environment, Natural, and then I click on one of these, maybe Nordic coastal cliffs, for example, and then filter by surface. I look through for the surfaces that I like, so potentially this shoreline here, and I'm going to click Heart to add that to my favorites. And then once you go through and pick all of the different textures that you like, you can go to the Favorites tab, and it's a simple matter of looking through the favorites that you've identified and then just clicking this little download button. And then once it's downloaded, this download button will change to an export button, and you can go ahead and hit export high quality, or just export. You can set the quality down here in the bottom right and repeat that process for all of the materials that you want to import. So I've already done that for all of my materials. I only need 5 for the time being because I only have 5 splat maps or 5 IDs that I can assign textures to. And I went for this gravel ground material, this layered rock material, mossy ground, shoreline beach, and tundra mossy, because I have 2 different grass types, which are going to be covered by the mossy ground and tundra. And then I have cliffs, as well as beach sand and kind of like rocky scree for both the beach and also for these kind of areas at the bottom of the cliffs. Okay, so once you've downloaded all of the textures that you want, you can just go ahead and filter by texture there, so that we can see all of the textures in the content browser underneath the Megascan surfaces. And then I'm also going to filter by _D to just grab those diffuse textures. And then I have a really nice way of just drag and dropping these textures into the texture array to fill out the landscape. So I know that my first index is going to be my grass. My second will be this mossy tundra. Okay. And then my third, this orange, is going to be the gravel, so the sea gravel or sand. And then we have our shoreline rocks is green, and our layered cliff is the yellow there. So I'm going to overwrite that. And finally, with those rocks. All right, so we've gone ahead and we've imported all of those textures, which we can now see are assigned to the terrain. But it's not looking that great, a little bit kind of higgledy-piggledy, and it's not really certain how well those textures are working together. Well, why is that? Well, it's for a simple reason that we've disabled our global color map. So I'm going to go ahead and tick back on use terrain color. So you can see that the error we're getting in the material instance is sampler type is color, should be linear color, which means that that texture array has decided to turn off sRGB. Also explains why it looks weird in the texture viewport there. So we just turn back on sRGB. Bit of a peculiarity there of texture arrays, and now we see that we're getting a much better end result. So if we zoom out, we can see we're getting all of that nice color information that we authored inside of Houdini. And now I think before we start filling out those other texture arrays, let's just have a quick look through these settings and what they do. So first off, we have this detailed brightness, which I will already be pumped up inside of the material because I found that the textures I chose to work with were a little bit dark. So I'm just applying this global kind of brightening there to the detail textures to brighten them up. And we also have a global color strength. So if we put that all the way to 1, we can see that we're getting all of that color there through an Alt-3 just to switch to base color. We can see we're getting all of that color that we authored inside of Houdini. But as we kind of get a little bit closer to it, we don't see any of that nice detail that we want to see from the tiling texture maps. So this global color scale here just allows us to decide the kind of cutoff point there between those two sets of textures. So that'll be down to personal preference. And I think that a value of 0.5 is working pretty well here by default. It's a little bit hard to judge because right now the specular is so high. So I'm just going to filter the parameters by specular, and for the time being, I'm going to set the global specular scale to 0, which lets us just see the color in isolation. Okay, so I think that's a pretty nice balance between the global texturing and the tiling textures there. You can see that's some nice variation up close from the global color map, and then in the distance it all holds together a little bit better. And then we have, of course, the detail brightness, so we can play with that a little bit more if we want the detail to kind of punch through slightly and sort of lighten that whole thing up. So I think I'm going to leave it on a value of 5. Okay, so I'm reasonably happy with that for the time being. And at this point, since I'm happy with my texture choices and I don't want to kind of go ahead and play with them any further, although you could of course spend a long time modifying this, I'm just going to go and hit browse to this texture array. I'm going to open up the normal texture and the masks texture once more. And then I'm going to focus on the normal texture and just replace those references to the correct references. Okay, so that starts to look a lot better now with all of that normal map information as well. And last but not least, we're going to go and set up those masks. Okay, so now if we just hold Control L and move the light around, trying not to have it be hidden behind the clouds there, we should be able to see that we get some specular. And if we don't, it's because we turned that specularity off earlier inside the shader. And now we can see those nice details in the roughness map punching through. Okay. All right. So yeah, that's it. And we've now set up our kind of basic first pass of the landscape inside of Unreal. And we can, in future videos, take full advantage of this kind of material framework using texture arrays and an index texture to carpet the landscape in as many layers as we need without running into the horrors of shader complexity or long compilation times that are usually induced by when working on these kinds of large landscapes. Thanks for watching, and catch you in the next one.